The next video talks about copying objects, and it also relates to Lab 8, which we'll talk about more next week. We talked briefly about copying objects, but this is a more detailed look at it. There are two types of variables in Java, primitives, which are the 8 primitive types: booleans, floats, doubles, ints, and so forth, and objects. So an object type could be a class, an object of a class. It could be an interface. It could be an array. And a reference to each of these object types is stored in the stack. And the object itself, the array, the interface, or the class, is stored in the heap. A primitive is just stored in the stack. So copying primitive data types is real simple. You just use the equal sign, the assignment operator, x equals 20 and y equals x. They're both ints. 20 is a literal integer, therefore they all copy nicely. But if you copy objects, it's very different. There's two words that we use: reference copy and object copy. So let's talk about a reference copy first, which is not really a copy, but it creates a copy of the reference variable pointing to an object. So here's an example of creating a car. My car 1 is equal to a new car. So the object is created in the heap, and my car 1 points to it. And then my car 2 is set to my car 1. Now notice there's only one keyword new. So there's only one object that gets created. But you have two references to the same object. That's not really a copy, but it's called a reference copy. Now an object copy creates a copy of the object itself. So in this example, we're assuming that there's a copy constructor of car that takes car 1 and replicates all the fields, and this would be an object copy. So now there are two objects pointed to by my car 1 and my car 2. The question is, are there any internal objects, an object inside the car object? If so, then that's called a shallow copy. So a shallow copy copies the main object but doesn't copy the inner objects. So the inner objects are shared. Student 1 is composed of a course in this example. Course name, and the course is an object that has two fields in it: course ID and course name. A shallow copy creates a second student object, student 2, but both objects share the same course object, so it's like this. Now, student 2 could change the course because he points to the very same object, sub-object. A deep copy, though, would create a separate, totally separate object in the course. So now if student 2 decided to change courses, it wouldn't affect student 1. Here's an example of a shallow copy code. Notice the red line here. They set this course, this dot course, to be s dot course, and s is the copy of the student that comes in. So this is a driver of the shallow version, and here are the two students. Student 1 is named John. Course ID is 1234. The course name is CMSC 203. Or the student, the equivalent to the M number is 1234 probably. But then, if we change the course, call change course, then student 1's course gets changed even though we called change course on student 2. A deep copy, the programmer has to understand how deeply the object's references go, but in this case, the student object has a course object, and the course object has only primitives or strings in it. So here's the driver, and in this case, when student 1 changed course, student 2 had the original course, so it didn't affect the second object. So here's another way of looking at it. Now, by the way, copying arrays is just like copying objects. Arrays are not objects, but they are treated the same for copying. So in this example, we have an array of dog objects, and each dog is instantiated. I call them pup1, pup2, pup3, pup4, pup5. Those are objects. And the array, first of all, the reference variable for array is puppies. And we use a couple things to say about this, and we'll get back to it. We'll state it again when we get to Lab 8. But the name goes outside the stack because the name of the variable never makes it into the machine code and never actually exists as the code is running, except in the JVM. So in the stack, though, for puppies is a memory address. We represent a memory address by an arrow. So anytime you see an arrow, you should think memory address. So this memory address points to an array of dog. And that array is of size 5, it looks like. So element 0 of that array points to an object called pup1. So when we say a reference copy, it's technically not really a copy. It's just passing the value in and then returning the same value. This is an example of a shallow copy. In this example, we have the same array of dog. Puppies is an array of dogs. And we copy the array one to one, one by one, in a for loop. But notice down in the down at the part where we're copying the pups, we copy puppy sub I into copy sub I. And this is the diagram over to the right that shows what it looks like conceptually. So puppies points to an array, and then we copy a new array into copy. Copy also points to this other array, but when we loop through copy.length, we share the inner objects. So this is a shallow copy. A deep copy, notice there's a total separation now between the two objects. And you'll also notice that there are two instances of the new keyword. New to create the array, and new 5 instances because we looped through it 5 times. New to create the new instances of dogs. Now, one thing we have to assume is that there is a copy constructor of dog. So that's the difference between a shallow array and a deep array, a shallow copy and a deep copy, rather. And once again, the same logic holds for objects as for arrays. If they are totally separate and don't share anything, then it's a shallow copy. So here's some examples of a memory map. Now, a couple interesting additional things to realize. First of all, the integer A is an array of ints. So A is an array of ints, and it's an array of six ints long. And so it shows up first in the code, and so it goes on at the bottom of the stack. Now, like I said before, A, the name of this array, is outside the stack, and the memory address is what is actually put in the stack. And so we have an arrow that represents the memory address. It points to an array of all zeros. The default value is 0 for an array. And then the second element is B, which is a primitive, an integer 1, 2, 3, 4. So we said before, and we will say now, that primitive data goes directly in the stack. So there's the primitive data. So it's kind of, it looks backwards. The first element to show up in the code is the bottom element on the stack. Here's an array called Z that just creates a number of strings. By the way, strings are immutable, so it doesn't matter whether we use a copy constructor or not. String is one of the few objects I know of, the only object I know of that is immutable. Here's a shallow copy. So the same logic holds as we saw a few slides ago. There's only one instance of new, that is the array that's copied new. This array is copied. This is the copy. This is the student's copy. We assume that there are 5 students already declared, already defined, and they're put in the array here. And then when we loop through, we just copy student sub I into copy sub I, and so we end up with a construct like this. So here's the equivalent version of a deep copy. Once again, we create the copy with new student, and what we end up with is that the copy points to a new array. But now, when we loop through each element of students, we copy the new student, again assuming that student has a copy constructor. We copy the new student into the copy array, and we have a shallow copy. So here's some summary. The main thing to realize is that a deep copy is 100% disjoint, whereas a shallow copy is not 100% disjoint, so that in the shallow copy we can expect that we have the possibility of leakage. So that leads to privacy leaks. When somebody outside, in other words, a client programmer, gets a copy of an object that the application programmer meant to be securely inside, and that's called a privacy leak. And when a client of a Java class can modify the value of a private attribute of the class. So we want normally for things to be private. And in this example, we return this student class returns a private object. It returns course, which is private, and the driver gets that course, and then they can modify it. So here's an example of an object created as a result of a privacy leak. So how do you prevent it? Well, you return copies of objects referenced by the instance variables. So in your course, instead of returning a course with exactly those objects, we return the instance variables of the course. So in this case, the student 1 tries to set the course name because student1.course is set to the different object. So why are we not worried about the name field? Well, because those are all strings, and the string class itself is immutable, which means unchangeable. That's a unique thing for strings.